So in this video, I'm just going to talk you through the marking scheme for complex numbers test in 5th year. So it says it's an 80 mark test. Okay, so you should be marking this as you go. So 2 minus 1 is a root of z cubed minus kz squared plus 21z minus 20 is equal to 0, where k is an element of the real numbers. Okay, I'll touch on that in a minute, that k is an element of the real numbers. It wants us to find the value of k. So z is equal to 2 minus I is a root. We know it's a root, it says it in the question. So therefore, it should satisfy the equation. If I were to sub it in, it should mathematically make sense. So that's what I actually go and do. Wherever there's a z, I sub in 2 minus I. You'll find then that there's only one unknown, and that's k. So I progressively go to multiply this out. So it's 2 minus I cubed is 2 minus I by 2 minus I by 2 minus I minus k by 2 minus I squared, so 2 minus I, plus 21 by 2 minus I, which would 21 by 2 is 42, 21 by minus I is minus 21I, minus 20, minus 20. I tidy up the 42 and the minus 20 to give me plus 22, and I slowly start to multiply these three brackets out. I do the last two first, so 2 by 2 is 4, 2 by minus I is minus 2I, minus I by 2 is minus 2I, which would give me minus 2I, and minus 2I would give me minus 4I. Minus by minus is plus, I by I is I squared. And then these two is the exact same thing, to give me 4 minus 4I plus I squared. I know that I squared is minus 1, so it's 4 minus 1 gives me 3. And it's the same here, 4 minus 1 is 3. So I continue to multiply this out, so it's 2 by 3 is 6, 2 by minus 4i is 8i, minus I by 3 is minus 3i, minus by minus is plus, I by 4i is 4i squared, and that gets tidied up. 4i squared, remember I squared is minus 1, so this is really minus 4, so it's 6 minus 4 is 2, minus 8i minus 3i is minus 11i. I don't multiply in the k, and I'll show you why not in a second. Over here on the right, I've moved that all to the right hand side, so it's minus 22 plus 21i, minus 22 plus 21i, and then I also subtract 2 and add 11i to both sides to get to here. So at this point, I want to get k on its own, so I multiply everything by minus 1 to get a positive k. Multiply everything by minus 1 to get a positive k, fine. What was there before I delete it? 24 plus. And then I'm going to divide everything by 3 minus 4i. So I've got a complex number divided by a complex number. I'm going to multiply top and bottom by the conjugate of the bottom, continue to multiply it out, and I'm getting k is equal to 8. So marks wise, even if you sub in at all, you're going to get 4 marks for that. If you get down to either this line, that line, you're going to get 7. And if you get it perfectly right, you're going to get 10. There is a second way of doing this question. We know that 2 minus I is a root. All of the coefficients, including k, are real. That's really interesting. The coefficient here is 1, the coefficient here is k, the coefficient here is 21, and the constant is 20. K is real. I know 1, 21, and minus 20 are all real. So as 2 minus I is a root, as all the coefficients are real, we can use the complex conjugate roots theorem. That's really important, being able to use the complex conjugate roots theorem. So this is the second way of doing the question. We know that 2 minus I is a root, so therefore I know the conjugate is a root. 2 plus I is also a root. Okay, so I have two roots now. Z is equal to 2 minus I and Z is equal to 2 plus I. Well, if I change them to factors, okay, so subtracting 2, adding I, subtracting 2, minusing I now have two factors. What do I know about factors? Factors should divide in evenly. So if I were to multiply these two factors together, I would get another factor that should divide into k, or into the equation to begin with. Z by z is z squared, z by minus 2 is minus 2z, z by minus I is minus iz, minus 2 by z is minus 2z, minus 2 by minus 2 is 4, minus 2 by minus I is plus 2i, I by z is zi, I by minus 2 is minus 2i, I by minus I is minus I squared. Lots of that cancels, as you can see. We're happy z squared stays there. Minus 2z, minus 2z. And here, 4 and minus I is 5. So this should divide in evenly into the equation. Remember, this is the second way of doing it. I don't know what my I don't know what k is, but I know z squared minus 4z plus 5 should divide evenly into that. So z by z squared gives z cubed. Z by minus 4z gives minus 4z squared, and z by 5 gives plus 5z, which leads us to this line. Next line in long division is to change the signs. Okay, well, part of it gets a bit funky. Z cubed minus z cubed, fine. Minus z squared plus 4z squared. Do that in rough work. Minus z squared plus 4z squared gives 4 minus k z squared if you just factorize out what we can, which leads to this line here. 21z minus 5z is 16z, bring down to minus 20. Okay, well, z squared by what is that? Is this? It's going to have to be multiplied by 4 minus k. So I'm going 4 minus k by that, 4 minus k by that, 4 minus k by that. Gives me my minus 4 by 4 minus kz. And 4 minus k by 5. I know it is a factor. I know for a fact it is a factor. So when I change the signs, this should be true, which leads to this. Minus 20, minus 5 by 4, minus 5 by 4 minus k, which is an equation with only one unknown, so I could multiply that out to get k as well. And look, it's the same k as the first one. Okay, so again, it's a 10-mark question. You would be looking for marks-wise, 0, 4, 7, 10. You're probably looking for 4 marks for saying that. Or actually, if you said anything along the lines of this, like that you can use the complex conjugate roots theorem, I'd be happy to give you the 4 marks. If you have it multiplied out properly and start doing some long division, if you start doing long division, that's fine. Like any start of long division, give yourself 7, and obviously fully correct, you're getting 10. Curiously, the next question for 15 marks is very much like the second method there. Now this is that question 1A was the only, 1A part 1 was the only question that has 2 methods of doing it. So we know that z cubed minus 8z squared plus 21z minus 20, as A, B, and C and D are elements of the real numbers, then we can use the complex conjugate roots theorem. 5 marks. So we know that 2 minus I is a root and 2 plus I is a root, so therefore we must know that z minus 2i plus I, z minus 2i minus I is a factor. So if you get to here, you're looking at 9 marks. If you start doing anything in the long division, you're getting 12 marks. And if you get the full answer at the end, so z minus 4 is your factor. Z is equal to 4, sorry, z minus 4 is your factor. And I should say another root. I think it says find the other roots. It does say find the other root. You're looking for 15 marks for having that written out nicely. Next question, changing to polar form, really gift of a question. You want to draw a diagram out, first of all. We know it's going to be 2 root 3 on the real axis and minus 2 on the imaginary axis. So a diagram like this, you're looking at, are you looking at 5 marks for that? You're looking at 5 marks for having the diagram and the modulus found, or the diagram and the reference angle found. So any sort of combination of those two, you'd be looking at 5 marks. I'm going to put the 5 there using the modulus formula. Finding the reference angle would get you 9 marks. So finding all 3 will get you to 9 marks. If you've just gone and found, if you did it in this order first, if you did it the diagram, the reference angle, and then went and found the modulus, you'd be getting the 9 marks. So hopefully you get what I mean by all 3. You'd be getting 9 marks for it. Theta, so I didn't specify whether it's in radians or degrees, so I've done both options. You can find theta in radians or degrees, so that would get you to 12 marks. And then writing it out nicely in polar form gets you to 15 marks. Okay, the next question is an application of de Moivre's theorem. It tells you the complex number w has a modulus 3 3/8, so I've just put 3 3/8 into the calculator and gotten 27/8. And it tells you the argument as well is 2 pi over 3. So if you get to this line, or even this line, you're looking at 5 marks. We know that this is w, but it also tells us v cubed is equal to w. So that means v is going to be the cubed root of w. But a cubed root can also be written as a power of a third. And when you see powers of fractions, you should think general polar form. So yes, you're putting it to the power of a third. But you need to, and if you do either this or this, you're looking at 9 marks, 27/8. So one of those two circles, you're looking for 9 marks. So I'm saying 5 here. 9 here. If you change it to general polar form, so making sure it's 2 pi over 3 plus 2n pi, well, we have to change it to polar form, so we're adding on our 2n pi's. If you get to the next line, this line right here, that's 12. So you've correctly applied de Moivre's theorem. Now, a lot of you will apply de Moivre's theorem correctly to the argument, modulus to the modulus, but you'll forget to apply it to the argument. So multiply by a third. So that would lead you on to this line as well for 12 marks. Then you need to go and do n is equal to 0, 1, and 2, because we know we should have 3 answers, because the question says 3 answers. Also, it's the power of a third. You do not need to change it to a rectangular form. Read the question carefully. It says polar form. So getting these 3 answers gets you the 15 marks. So we have V0, V1, and V2. The next question asks us to graph them. We know they are all a distance of 3/2 from the origin. Remember, that's the modulus. They are all a distance of 3/2 from the origin. So that's why I've drawn out a circle here for 3/2. For 3/2, you're drawing out a circle because they are all going to be on that circle. We know there are 3 angles that I need to deal with. There is, well, remember, pi is equal to 180 degrees. So pi over 9, I will mute that. Pi over 9 is equal to 20 degrees. So 2 pi over 9 is equal to 40 degrees. We're going to know that 8 pi, so I just multiply by 2. Now I'm going to multiply by 8. And the next one I'm going to multiply by 14. 8 pi over 9 is equal to, what is it? 160 degrees. And 14 pi over 9, what's 20 times 14? 220 times 14, 280. 280. Oops, that's not what I want. That's not what I want either. Delete. 14 pi over 9 is equal to 280 degrees. And you can actually see these degrees here. Look, 40 degrees. This one. And 280 degrees. And it's rough, but it's fairly accurate as well. So one of them you'd get 2. Or actually, if you drew the circle, I'd get, and it's the correct radius from the previous question. So if you got the previous question wrong, but you're using the correct radius, it's absolutely fine. If you, from the previous question again, use the wrong angles, that's fine, you'll be getting the 2 marks. If you plot 1 or 2 of the points correctly, give yourself 3. And if you've got it fully correct, give yourself 5. Now, if you've got it fully correct, and so if these answers are wrong, but you graphed them fully correctly, you'd give yourself 5 because you're answering this question correctly, even though you've answered this question up here incorrectly. Okay, this nice little short question here, you're looking at 0, 3, 5. Hopefully you remember that i's are cyclical, so whether it's I, then I squared, then I cubed, then I to the power of 4. If you keep multiplying, I'm multiplying by I, multiplying by I, multiplying by I, you're going to get I to the power of 5, multiplied by I. Again, you'd get I to the power of 6, I to the power of 7, I to the power of 8. So they keep going around in a circle. So if you look at the powers, I've just subtracted 4 until I'm down at 41. And then I've subtracted 4 times 10, or 10 times 4. And I've gotten down to I to the power of 1. So look, if you've done something like subtracting 4s from the power and didn't get it right, you're giving yourself 3. But if you've gotten it fully right and just said I at the end, you're getting a 5. Brilliant. Next question for 10 marks. We know complex number z is equal to 5 plus 3i. We know we want to find w. We know this is z multiplied by w. So you'd want to divide by z. Divide by z. So if you've done either of those two things, you're looking at 4 marks. If you've then multiplied top and bottom by the conjugate at the bottom, you're looking at 7 marks. And then correct answer at the end, you're looking at 10 marks. Last question then of proof of De Moivre's theorem. Now this question doesn't ask you to actually prove it by using an or. Look, there's no modulus. Okay, so I have gone and proved it with the modulus, but you don't have to prove it with the modulus. I'm just going to fly through the marking scheme of this because look, you've actually got the video yourselves on YouTube. So prove De Moivre's theorem. So I've proved it with the ors. If you proved it with the ors, brilliant, you're going to get full marks. If you've gotten down to this point here, you're getting 4 marks. Okay. If you've gotten down to here, you're getting 7 marks. And then for fully correct, you're going to get, so, and fully correct sort of implies all of that, including that last little bit at the end, okay? If you're missing that little last bit at the end, give yourself 9 marks instead of the 10 marks, but this bit at the end is important. Yeah, and that's the marking scheme talked through. It's actually not the marking scheme talked through because it's not out of 80, it's out of 85. Hopefully you noticed that.